Hi everyone, welcome back to the session 3 of ML algorithms coding that we were doing. In the last session, we discussed about the logistic regression and where we and we'll be continuing this session for logistic regression only. In the last session, I told how we can create a simple logistic regression. Uh, However, there were certain improvements that we can do to that logistic regression model that I'll be explaining here, that and the implementation of those. So there are two things. First thing is like we can add for to avoid overfitting, we can add regularization parameters to the code that we have written, and there are basically generally two types of regularization that we use, either L1 or L2. And here we will explain like how we can implement the L2 regularization in our code. Second thing is for gradient descent, what happens is when we have too much or too big of a data set, it's not a very good or very efficient way of computing gradients, because it takes all the data points that we have and computed gradient at only one point. So for millions of records, this thing might go out of memory. So to make it more efficient, what and more accurate, we generally use stochastic gradient descent, in which the main difference is it takes one data point at a time instead of taking the whole all the millions of data points at once. And one generally that is also a very good way, but like if you have millions of entries, then all that thing also become limiting in the fact of we have to compute the gradients for each and every data point one by one. So the more efficient way than this also is the batch gradient descent, in which what we do is like we generally take a batch of k entries and then perform the stochastic gradient descent on those entries. Okay, so before moving further, before I tell you like how we are going to do gradient descent, here is one blog article that I found out about L2 and L1 regularization that might give you a better idea. So in this particularly, it explains like we have two regularization mainly techniques. L1 is called lasso regression and L2 is called a ridge regression. So generally in the key difference between two is how we add the penalty term. In the L2, what we do is like we add the square root of magnitude of coefficients as penalty term to the loss function. Here if you can see like the highlighted part is the L2 penalty regularization element. And the L1 that we have is lasso regression. It's like it's also in like if you try to understand it, also it's also called least absolute shrinkage and selection operator, which adds a absolute value of magnitude of coefficient as a penalty term to the loss function. And one of the things that you can keep in mind, but I'm not sure if it's that important at this point, is like the key difference between these techniques is that lasso shrinks the less important features coefficient to zero, thus removing some features altogether. So this works well for feature selection in case we have a huge number of features. So yeah, let's go back to the coding part that we have. So now when coming on to this thing, one of the major updates that we did is like the regularization parameter L2, and in which we specified the strength is zero point 0.1. In this we are saying, since we are taking mini batch HDD, we are specifying batch size equals to 32. In this we are just initializing things. Then in the fit, what we are doing is here in this particularly we are taking everything in batches, x in batches, y in batches, and then we are calculating the z that we have, then we are calculating the sigmoid of this that thing, and then we are calculating the cost that we had. So this thing is almost similar to what we had did till now. However, in the further part, we are calculating the regularization term. In regularization, what we are saying is for L2, we are saying strength divided by 2 into number of samples into self dot weights square of self dot weights. And in L1, what we are doing is we are saying like np dot sum absolute self dot weights. So if you just remember what I told you in L1 and L2 regularization, it's nothing but writing those particular thing in the coding those particular things, and then updating the cost with the regularization parameter. And once we have calculated the cost, we try to calculate the partial differentiation with respect to the weights, with respect to the biases that we have, like update the gradients. And then once we have that thing, like if we are taking L2 regularization, there would be one term in gradients. There will be one change in terms. And similarly, if we are using L1 regularization, that will be the change in terms. And then we are updating the weights and biases with the gradients that we just calculated. And then once we have updated the weights and biases, it will go on in number of iterations that we have one by one, and it will then compute the final value of the weights and biases that we have. So if you want to predict, then we use just directly use weights and biases and then segment and then return like whatever final categorical values that we have. And similarly, the sigmoid is defined as 1 upon 1 plus exponential raised to the power minus z. So if you do not understand what we basically did in logistic regression, I recommend you to please go to the session 2 of this particular series to understand how we coded a simple linear logistic regression model. So this implementation just included the two improvements from the earlier part is like we added regularization option and we did mini batch stochastic gradient descent. And then in particularly, if we want to test this thing, what we will be doing, like we'll be passing through the initial sets, then the initial y variable, and then running a logistic regression with L2 and learning rate and number of iterations. And then for newer values, we'll try to predict. So mostly the answers that we got were almost similar, but like if we consider bigger data sets, the answer might differ. And if we try to visualize what we just did, so generally, it's very hard to visualize what's happening in logistic regression in multiple dimensional. However, for a 2D data set, we can visualize a boundary, decision boundary for logistic regression. So this is nothing but till here what we have seen, and for here what we have tried to do is try to plot taking different values, and it's like taking I think what linspace does is between 0 and 6 take 100 different values, and between 0 and 8 take 100 different values, and then we pass these sets of variables as y, as x, and then we want y values from this thing, and then we want the final values. So this is how a dimension how it looks like. So before this I think it would be 0, and after this it would be 1. So I hope you understand this thing, and in case of any reviews or feedback, please let me know in comments. Thank you.